Good afternoon, everyone. Thank you for taking the time to join our Vivid webinar, which is going to cover today the HPLM less test cases, more coverage subject. Next slide, please. My name is Mihai Grigorescu. I will be your moderator for today, and we will be taking you today to the talks around around the data maker tool and grid tools and grid tools. We are bringing this webinar to you through our own Vivid Testing Quality and Application Lifecycle Management Special Interest Group, which is TQA and SIG. Next slide, please. That is me. I am actually the chapter leader for South Africa for Vivid and the testing capabilities for Accenture South Africa. I will not be talking today as we typically do, so I will be presenting the speaker for today, who is Hugh Price, over here, the Managing Director for Grid Tools, Platinum Implementation Partner for HP, and as well one of the single data management framework tool makers out there in the market. So next slide, please. All right. For those of you who have attended our previous webinars, you are probably aware of our housekeeping. If not, then you notice that this live session is recorded, and the recording will be made available after a couple of days, and you will receive a notification as to whether the recording is set up on the Vivid website. We will have a series of questions and answer sessions at the end of the presentation. We will also be doing the polls at the end of the presentation. So please type away all your questions as you go along through the presentation from Hugh. We will only tackle the questions, however, at the end of the presentation. Those are the basic rules. So sit back, relax, and enjoy. Before you do that, if you don't know how to work with the webinar control panel, this is how you do it. You can actually set up your Windows your window into full screen or just minimize it, and you will type your questions in the chat box. You see there's a questions and chat box that you have at your disposal, so type your questions in there, press send, and we will get your questions on this side and have them answered at the end of the site, at the end of the presentation. Next slide, please.
Okay, Mihai, shall I pick this up?
Well, I think you should. So enjoy, and everybody in the room just relax and enjoy what Hugh has to say. So Hugh, over to you.
If you do have any, if there's any problems with the audio, please, if you could just jump back in and let me know or send me a message, because sometimes gremlins do creep in. Thanks, Mihai. I'll just get going. Okay, so I'm going to mostly do a slide deck, but if I've got time, I might actually just jump into the tool. Sometimes it's a little easier to kind of see the tool in action. So, challenges, ambiguous requirements. 56% of bugs actually come through from poor requirements. And it's. I would say that the requirements we look at, especially if they're very heavy in English, are actually very difficult to interpret, and they have to be interpreted not only by the programmers, by the testers, and by the users. Also, test cases are currently manually designed by hand. I ask this question all the time, and people say to me, "Oh yeah, we designed them manually. Oh, we just read the requirements document and build them." So, most test cases are actually manually created, and you say, "Do you use any kind of tooling?" and they'll just say, "No, I've got lots of experience." One of the problems then is if I say, "Well, what kind of coverage have you got with your test cases?" Actually, there really is no ability to gather functional coverage, functional logic, statistics for test cases. There's not really a sort of clear methodology for that. Another problem is kind of reusability of test cases. You know, your developers might have some nice unit test cases and your functional testers and your integration tests. And actually, there is quite a lot of commonality in terms of the test cases that are being passed up and down through the development lifecycle. And of course, this is one of our pet projects is, you know, better test data associated with test cases. You know, I need this particular type of process, this order in a particular state to be linked to this particular test case. So actually trying to tie your test data back into the test case is actually sort of fairly fundamental. And, you know, very, very poor complexity analysis. What I'm saying by that, we did actually do a whole webinar on the ability to define how complex a process is, how long it's going to take to develop. You know, the IT industry is, you know, is one of the few industries in the world where most projects, you know, you have no idea how long it's going to take, and you have no idea whether you're going to hit any deadlines. You know, the electronics industry doesn't operate like that. You know, the building industry doesn't operate like that. So, you know, we really do need to kind of include better complexity metrics when we're actually trying to predict how long something is going to take to actually bring to fruition in the software development lifecycle. So, moving on a little bit. So, what we've really taken is kind of the inspiration from hardware testing. I mean, if you're sitting in front of a computer at the moment, if you've got an i7, which is a very nice little processor, you've got 40 million logic gates in there. And, you know, the software industry does tend to think of itself a little bit like some kind of subjective art. It isn't. It's basically, you are thinking, you know, you want some software to do something. It's a circuit board. The requirements need to be solid. They need to be unambiguous. And when you build your test cases, they need to be use mathematical methodologies to actually build those test cases. And that will then actually kind of move you into accurate coverage statistics. Have I tested this logic gate? You know, the hardware on the computer very, very rarely breaks. It's only when you actually add some software do things go wrong. And, you know, what we're really talking about is the ability to test hardware with billions of logic gates, really. I mean, how do you do that? How do you actually test those billions? How do you test those millions? And it's really trying to use some of the techniques that are actually used in the electronics industry and apply them to the software industry. So, what is coverage? One of my favorite questions, and I always get different answers. What sometimes people, they may well have heard of code coverage. And code coverage, you know, the reality is that you don't actually want to get to 100% code coverage. If you've got good error handling, you would never go down some of those paths. Code coverage has its uses, but it's very good to notify changes in code, really. That's kind of where it comes into its own. What I would say is most people's definition of coverage is, you know, I've designed 20 test cases, I've run 20 test cases, and they all worked. I've now got 100% coverage, and that's kind of what they mean by coverage. Then I'll say to them, well, do you get any bugs in production? Oh, yes. So they've got 100% coverage, but they've still got bugs. They might say it's a percentage of use cases. You know, we've run through the various use cases with our user. There's 23 of them. We've been through them. We've tested them. We've got 100% coverage. And another one is really, which is quite a lot of testing tools are used, what we call all-paired combinations, which I will talk about in a little bit. But basically, the idea with coverage is designing sufficient tests to verify that the design and code correctly implement the requirements. And what we're really talking about are the functional logic that we're actually defining. Not the functional points, but the actual functional logic. And another thing to really bear in mind is, did you get the right answer for the right reason? Very often, two or more defects may sometimes cancel each other out, and you really need to sort of factor in this concept of observability. Why did I get that answer? Why did I actually pass through that particular that logic gate, and why did I get that particular expected result? So, this is a sort of typical requirement. You know, lots of words. Business client or preferred, it's got an or statement, it's got an and statement, it's got a no in there, it's got in the last, you know, which is a temporal definition. Otherwise, you know, it's got typical sorts of linguistic problematic areas. And really, when we start looking at requirements, you know, it's the kind of wall of words. It's very difficult to visualize that. It's very difficult for a user to agree that's correct, and one person's interpretation of it may actually be different to someone else's. And really, in this particular case, there are 64 possible combinations of input. And if you're going to design some test cases for it, which ones do I choose? How do I actually build the test cases for that? So, coming back to combinatorial, all paired, or constrained all pairs. Constrained means that some things can not occur together, some events, and also then you have the concept of some things must occur together, which is fine. And the work that you do on using kind of the all pairs tools is actually a very good way of being able to verify that you've actually kind of got a reasonable requirement. So the work you do defining the all pairs is actually all to the good. The problem is it doesn't really support expected results. So you may build an all-paired combination. I'm going to assume there is a knowledge of all-paired. If not, you might want to just nip off and do a Google search on all pairs while you're watching. And the problem is that you actually have to work out each expected result. So I have a particular set of combinations of activity that's going to come into a process, and it's going to post the order. Was it supposed to post the order? I don't know. I've got to go back and read the requirements and see, based on those inputs, whether that's the actual output. What combinatorial techniques do is that they accidentally increase functional coverage, and only to a point. In effect, you are randomly generating a set of inputs in the hope that you're going to increase the functional coverage. I would say that combinatorial will normally get you up to about 50% of your kind of logic gates. It also does not give you any solid metrics on how good your testing actually is. You can only infer that X out of Y combinations have been covered, okay? But it has no bearing in actual functional logic. You'd still have to go through each test case and actually see if I'm going to create a new order. Does the order already exist? Yes or no? That's a logic gate. So you have to have two logic tests there. The other thing that you do tend to end up with quite a lot of false errors. You say, oh, that shouldn't have happened, and that's really because you've actually got to go through then and check that the inputs actually don't make any sense, and then you go back and actually introduce another constraint. So it does actually take a fair amount of time to build sort of combinatorial all paired with constraints. So that's one technique. There is another technique which is very effective, and this is probably the one that's used most often in kind of event processing. And this is a thing called cause and effect graphing. Richard Bender's tool, RBT, being kind of world leader in this. And this really, this idea about being able to almost draw your logic as a, if you're an electronics engineer, you would very much recognize this sort of type of diagramming techniques. And this is actually quite good. If you see that C is C and F are not observable events, A is stuck at false, and basically it's one particular way of being able to draw out the test cases that we need to build. And it also brings in the concepts of observability, which is very important. Now, the reason that we actually incorporate the cause and effect, the RBT cause and effect modeling engine in the tool, but one of the problems is that it's not widely adopted, and it's actually quite difficult to use. Probably out of 100 people, you'd be lucky to find 2 people who can sort of consider themselves to be experts in using this particular technique. It is very effective, of course, however. So the one that we're going to talk about is kind of optimized path modeling, which uses sort of advanced graph optimization. And what we're really doing is using a flowchart. If you look at most Agile worlds, Agile boards now, where you go to an Agile room, you'll actually find a flowchart. There's a flowchart on a wall. It's very visual. If you get people together in a room to describe a requirement, they'll actually just draw pictures. And actually, we're using the kind of visual cortex to help you understand a problem. It's very difficult with words to try and actually conceptualize what's actually happening, whereas pictures are really good. You get similar results in terms of the actual number of reduction in test cases. It also supports looping, because you can go back round, which actually cause and effect is not very good at. And it also supports constraints. Constraints, this and this must occur together, and this must not occur together. There are certain applications where it doesn't really work, and that's sort of non-sequential based logic, where you've got sort of complex event handling, etc. And that's where cause and effect really does make more sense. So those are the more coverage techniques. I will show you a little link to some videos we've got on our website, and if you're really interested in this, there is, so we've got literally hours and hours of videos which talk about these different coverage techniques. So the other thing to think about is that what happens when you're actually, people do the same work over and over again. They might actually build a requirement, a functional description of it. They design it. They then come across and design some test cases and design some test data. And what we're doing with Agile Designer, which is the tool I'm going to show you, is that it allows you to do more than one thing at the same time. So you can build your requirements in the tool. You can also build your test cases. You can also build your test data. You can also estimate your complexity. So, I found that a lot of tools, if they don't really bring some kind of benefit, people don't use them. Whereas if a tool gives multiple benefits, then there's a lot more reasons to go and use it. And that's really what we're focusing on. We've got customers who use it to actually build the requirements. Oh, and by the way, here's your test cases. I spoke at an IIBA webs meeting, which is the Business Analyst Institute, and I said, the reality is that you should be able to build the test cases at the same time as you build the requirements. They looked a bit shocked, but actually, if you think about an agile sprint, that's exactly what you should be doing. The test cases should come out pretty much on the sort of day 1 or day 2. So, the idea is that using flowcharts, you design the requirements in terms of individual design or functional steps. The direction of flow between the blocks is unambiguous, unlike free-form text. It's either a true or a false. It either does it or it doesn't do it. If it's later, then you need to put in a block which says, a time event, and then you use that and you use a loop. So basically what you're trying to do is to use, the old-fashioned flowchart, which used to be sort of flavor of the month and has now moved out in terms of fashionability, and actually use that to drive the definition of the high level, medium, and low level. And this is something that programmers may well do themselves already in terms of interpreting something that exists in textual form. And all we're doing is bringing it left. We're shifting it left. We're getting it done earlier. We're trying to do the hard thinking much earlier in the cycle. And this is where you get all the benefits then of continuous development and continuous integration. So this is a little example of a flowchart on the left-hand side there. And what we do then is now this one I'm showing on the screen is basically what we're actually up to here is this is actually a fairly low-level description of a process, and it's actually something that exists. It's actually one of the specs that we use for Agile Designer itself, which is the concept of cloning. You can't clone something that's already a clone. If you unclone it, what happens to the children and all that type of stuff. So if you take a look at that in Agile Designer, hopefully you should see Agile Designer. Just check the audience view. Yes, you can. So within that, what we've got then is we've drawn that, but then the sort of magic really is that, and if you're used to using Visio, you've got all the normal stuff that you would normally use. But then what we've got is we've got various different optimization techniques. So that's going to say for this particular flowchart, there are 7 particular ways that you can make your way through it. In fact, I'm just going to open up a slightly different flowchart, just one with a little bit more meat in it. So we can take a look at it, which is change a light bulb. This was actually a response to how many testers does it take to screw in a light bulb. So I created this visual flow. And the answer is 3, by the way, because you actually kill off 3 testers. Now, this is a sort of medium-level process, and you can see, these are the processes you would go through when you're interested, when you actually want to change a light bulb. Now, it's relatively straightforward. It's pretty easy to understand. You can print it out. You can look at it. And it has all of the visual cues that you would normally use in defining a process. But when you kind of start looking at sort of optimization, if we take a look at all possible paths, there are 33. Now, I'm not including looping at the moment. I haven't got time to do looping. But basically what you're doing is as you click through that, you'll see here, these are some of the paths that you would need to build as a tester to actually design these test cases. Now, there's 33 in there, and that's quite a lot. And you often get up into hundreds of thousands in terms of the potential or possible paths. Now, what we've got then are these various different optimization techniques. And if we go to all nodes, now we're using some graphing terminology here. All nodes is saying, basically what I'm doing here is I've come up with 3 test cases which actually touch each functional point. I don't care about each logic gate, whether I'm turning left or right, or left, right, or straight on. All I'm literally doing is just making sure. And those 3 test cases would give what we call weak coverage, which is fine. There's nothing wrong with that. And then you move into the next one, which would be all edges. Now, all edges is 6, and this is basically saying that there are 6. If I pick these particular 6, and we're using sort of some pretty strong mathematics in here to pick the optimal 6, that's then going to push through. And if you've got a decision gate, we will have created one of the test cases will test that decision gate. Okay? And then the strongest one is a thing called all in-out edges. Now, in-out edges, there are 10 of them. So if there's 2 ways into a functional piece of logic, we will have 2 ways in and 2 ways out, which is 4. And what we'll do is we will merge together other in-out logic to come up with the smallest set of test cases, like so. So this is kind of, the way that you would actually think about building these test cases. And the last one is all pairs. Sometimes all pairs does make sense if you've got configuration testing, if you've got things like different types of browsers, for example, different types of mobile devices. The potential combinations is just too large. And then all pairs, in this case is 21, is sometimes the best way to do it. It's very good for configuration testing. Now, just a couple of other things. If we just go off and look at what we call graph modeling has been around for a while, and you can have a look at graph modeling. You can download some kind of shareware tools. But really, the kind of key thing is that they don't really handle what we call path hints. Now, path hints are actually constraints. And there are certain activities within a logic flow which imply things lower down. So if, for example, I couldn't possibly go in an ambulance if actually the power's off. So there's no reason for me to do that. So what we're doing is we must not occur combinations and must occur combinations. And this is really the thing that actually brings what we call the optimized graph modeling into its own, because by applying these constraints, which are actually requirements, they're actually requirements if you think about them, to the optimizer, it allows us to actually build the perfect set of test cases to test all these logic gates. Okay. The other thing to look at is this little dollar, and that's giving us the cost and complexity, but it's telling us how much coverage we've actually got in our existing test cases. Now, the way that we work is that we've got some very clever mathematics which will decide on the best test cases. And, I sort of challenge any tester at some of these testing shows to see if they can come up with better test cases than the tool. It's a bit like playing a computer at chess. It always beats you, and it does it a lot quicker. So that's actually building the optimization techniques to actually look through the logic and build the test cases. The reverse is actually counting, which is what am I actually doing? So if I already have 3 test cases, which I do in this case, what we do then is we actually just count to see in those test cases which particular, and the zeros mean that we haven't actually tested that logic gate. We haven't actually tested this gate. We've always gone down here. All our test cases go down that route. They don't go down that route. And all we're doing here is actually counting. We literally just count. And you can import your existing test cases, and I'll show you that a bit later. Okay? So that's really kind of the brains of the operation. And then also, you've got other various things in there where you're actually kind of including your test data and all sorts of other interesting things as well. And once you've got your test cases, you can also pump them out then back into Quality Center, and they would then appear in Quality Center. And if we look in Quality Center, you'll see we've got our design steps like so. And for this particular one, we've actually attached some data to it as well. We actually create a resolved description in Quality Center. So, and this is a manual test that you can actually then just run inside Quality Center. And then, of course, you could then potentially run an automated script, because we will also include the test data that you need. Anyhow, coming back to our presentation. So that's building the test cases. You create the flowchart. We can import requirements from Quality Center, and we will break them down based on the paragraphing into logic blocks. We can import them from Word documents. So we do have some pretty sort of powerful tools to help you build the flowchart. And as I said, we've got all these various different optimization techniques, which are pretty powerful. And then, as I said, we've got our test cases. And what we also do out of this, we come up with what we call a complexity number. And what this allows us to do is it actually then allows us to go off and to, in effect, calculate the complexity of a particular process. So the idea with the complexity is you can up the values on this, is you're actually predicting how long this piece of software should take to develop. Now this is based on what we call the testability. We're actually just working on a new product which is actually relatively straightforward. It's an automation framework. However, to test it is going to be extremely complex because there's an enormous number of potential combinations of things. So in terms of the delivery of that product, it's actually going to take quite a while to actually run through all the different test cases and test scenarios. And using testability as the measure of complexity is actually pretty radical. There's only one or two other companies that have actually sort of used this. In the olden days, HP and IBM used to kind of be quite good at this about 30 years ago, and this was predicting how long a piece of software would take to develop. They seem to have lost that ability. It's not something that you see appearing nowadays in terms of you know, a sort of standardized process to do that. There's various books out there you can buy. But what we do is, because we can calculate the minimum number of paths to test all the functional logic gates, that actually gives us our complexity. And what we find is that that complexity pretty much maps directly to kind of run rates in Agile world, or sprint points. And the thing to do is, once you've completed one or two sprints, you can then sort of almost throttle it and say, right, okay, if we've got a complexity of 1150, then that actually means that that's going to fit inside a sprint. If it goes to 2000, we're going to have to split it over 2 sprints. It's also very, very good for outsourcing, because the problem with outsourcing is if I make this change, we can calculate the difference in complexity. And that's very important, because that really does allow you to budget correctly. It allows you to actually say this piece of development is actually going to cost this, and you can stick to it. And in fact, what you can actually do is ask your outsourcers to bring the flow charts of the test cases to you before they begin. You, as the user, verify them, and they say, cool, that's fine. And then they say, right, that's going to be 1,000 complexity, which equates to $20,000 of actual real money. The next time they have another piece of development, it has 1,500 complexity, and you'd say 30,000. So it allows you to actually stabilize your outsourcing and predict how long a piece of software is going to take. Now, you know, this is come out of optimized graph modeling, and you get your test cases, and you get your complexity. So I think that's kind of one of the major benefits in terms of this kind of approach. Just to finish off on this, I mean, the other companies that talk about this, they actually say, I said to them, how do you build the test cases? And they say by hand. So the reality is there, you kind of becomes immediately a subjective art again. So using mathematics to predict it is kind of the way to go with this. So from flowcharts come paths, as I've mentioned. Paths are, through a requirement, can be use cases and test cases. So I'll actually just jump back to Agile Designer. I was actually, if you download the tool, and I would encourage you to do that, because it's pretty easy to use, and it's there's a free 15-day trial. This is actually a use case for those of you who are familiar with basketball. I was sitting with a guy who gave me the rule for whether it's a offensive foul or a defensive foul, and all we did was he literally sat there for about 10 minutes, and we created a little flow chart. And then what I did was I said, well, okay, let's have a look at use cases, and I just went through the use cases with him, and I said, okay, is that correct? And he went, yep. Is that correct? Yep. And we just actually literally sat together and went through to make sure that all of these results, descriptions, and expected results were actually correct. So if you think about it, what we're actually doing at that stage is we're really just doing a static test. We're actually verifying something with our users before we start. You know, and this comes back to the 56% of bugs actually come from the requirements, this ability to verify with the use cases. Now, the test cases that you actually build probably wouldn't be recognizable as use cases that the user would be interested in, because we're now more interested in functional logic gains. And that's where the optimization techniques come out. But they are two different parts of the same tool, and it's a very, very useful way of verifying you've got things correct. Paths are generated using mathematics, which is obviously better than humans. You know, one of the things we do is, once you download the examples, if you just try and actually build some test cases manually, which is actually pretty straightforward, all you've got to do in the tool is literally go in, click on the plus and just drag over stuff like so. And I'm going to do that one. And then it's basically just highlighting the next things that I can do. And I'm going to attack the torso, and I'm going to do that. And that's a test case. And that's pretty much how you design a manual test case. You literally, it will color it as you're moving through, which is quite neat. And you can use it to put manual test cases in. There's no problem with that at all. But it's quite good then to actually see, if you click on the dollar, you're actually looking to see what kind of statistics you've got. And here I've got to 100 because I've already done it. The other thing that we're going to talk about a little bit is this thing called over-testing coverage. What you'll find is that people will actually test too much. And this is really where what we're looking at is that people have created a whole bunch of test cases which actually, you've actually tested this particular one to death. This one's 5. We've actually got 5 test cases doing that. So this, we're kind of overkill. I would say that probably over-testing should be sub 200%. 150 to 180% would be probably optimal in terms of over-testing. And that's testing the same functional logic gate more than once. Okay, so that's something to think about. So parser-generated mathematics ensures the coverage can be measured and can be optimized. Okay, so test cases being parsed, we check for uniqueness. The other thing that you find actually when we import test cases, and we can just literally drag them in from Quality Center. We literally just drag a folder in, and it creates all the test cases. You find that they're duplicates. There's lots of test cases never die. People are very reluctant to remove test cases, but you find that actually the same thing has been tested, has been created by maybe a functional tester and an integration tester. So the ability to remove the duplicates is kind of, is a very useful way of being able to improve your testing. And also this other thing is that you can actually, if you kind of merge your tests, your unit tests, your functional tests, your integration tests together, you can actually kind of move tests up, reuse the tests that have been designed earlier. So just to give you some examples, now this is just one example. What we've done now is we've done a load of these where what we've actually recreated, we've taken a requirements document and we've actually built a flowchart out of a requirements document. Now what the tester had to do originally was read the Word document, which was in text, and create the test cases by hand. And this is just one example, but the reason I picked it out is it's fairly typical. It took them a long time to build those test cases. 5 hours to build, I think it was 14 test cases. Now when we imported the test cases into the flowchart, which we created by hand from the requirements document, we found that they were actually only covering about 16%. And I would say for most manual test cases, you're probably going to be sub 30% in terms of functional logic gates. You're definitely not doing enough negative testing. And manually going through, and what you find is people running their fingers down spreadsheets trying to make sure that they've kind of tested things. So it becomes really, really tedious to do that and very, very time consuming. And obviously we're using a tool, so we just bung the flowchart in, stick some constraints in, and bang. In this case, we actually created more test cases than they did, but you can see that at the 16% level, they're actually doing a fairly poor job of being able to actually test that particular requirement. And actually, when we asked them, we said, what happened? And sure enough, this function had bugs all over the place. So, and out of the 326, they came up with 14, and those 14 covered 16%. And once you use this, the number of bugs shrink down dramatically. A, because you're kind of defining it better earlier with the use cases, and then B, because you design it, you're finding test cases that find bugs at an earlier stage in the life cycle. The other very big thing is change requests. Nowadays you don't get a clear requirement. You literally just get an initial requirement, which might be very loose, and then a ton of change requests. The trouble is you've already created test cases. What do you do? And what we're finding is people are actually going through those test cases by hand to see if they've changed, and then maybe building 1 or 2 extra ones. Whereas the reality is, in our world, you just change some logic gates in the flowchart, repair the test cases you've got, and automatically create the new ones. So it's pretty straightforward to be able to create these new test cases, as you need them. So the problem is where do you start? If you're going to switch to using kind of optimized path modeling, should it really be the business analyst? Should it be a user? Should it be the project manager? Should it be the test manager? Should it be the tester? And the answer I would say is it depends. I would say that most testers can pick the tool up very, very quickly. And once the testers have actually built some of the flowcharts and gone back to the BAs and said, is this what you thought I was testing? The BAs will pick it up. Sometimes programmers use it. Sometimes actually programmers will go off and just build it themselves to verify that what the business analyst has given them is correct. And of course, once the programmer does that, then they get the test cases as well. So it does tend to kind of flow up and down through the life cycle. Some people use it as an accelerator, and some people embed it into the life cycle. So let's look at the HP Test Case Factory, which I think you can contact your HP sales rep if you're interested in this. And this is now where you've got thousands and thousands of test cases, and what you want to do is you want to go through and optimize them. You want to kind of cut the amount of, it might cost you $200 to run one manual test case, and if you can reduce the amount of that testing, that's hard money, that's hard dollars in terms of how, of the cost there. So what we've done is we've actually created almost like a test case factory, and actually you'll see in the tool a thing called Test Factory. And what we're going to do is we'll just drag in from Quality Center your test cases, and we'll drop them onto the palette, and then we go through this process, which is the palette on the left-hand side, removing duplicates, looking for duplicates, relaying it out, and building an optimized set of test cases once you've been through that process. And basically, you just drag it in, take it, you go off on the left-hand side, drag through the pane, and drop it into the palette, and the palette then goes through a series of steps, which are all very mechanical. However, so if we just take a look at this one, we import, and this is, web service, open login screen, main site, inbound service, timeout. We've got 5 test cases, and this is relatively straightforward. We're going to look for duplicates, and we're going to then optimize them. So if you look at the actual design steps in sort of HPALM land or QC land, you'd see there's a certain commonality in terms of some of those names, and that's where we kind of are in effect looking for the names that are duplicated, and you'll see A occurs 4 times, B occurs 4 times, C occurs, and so forth. And what we've done is we've actually said that these test cases are actually covering the same design steps. Now, what we've built into the tool is we actually go through this in quite a systematic way. One of the problems is when you're looking inside, I'll just jump off to ALM here, if you're looking for design steps, you're looking basically at text, and most people will have done a lot of cutting and pasting. Most test cases seem to be in spreadsheets and then make their way into Quality Center. And you can see that there's going to be some commonality between these design steps, and what we're looking for is to see actually if these are the same design steps. And what we're doing is we're actually going through, and we go through looking for duplicates. Now, there's a whole bunch of algorithms, as you would expect with us, to be able to pattern match. If it's come from a previous block, if the descriptions are similar, if the next block names are, the expected results are similar, then these are obviously probably the same type of design steps. And what we're really trying to do is to actually go through what was a very flat structure, and we're actually going to reverse engineer a flowchart out of your test cases. Now, it's quite funky. I've got to say it's quite impressive when it works, because what happens is once we've put the test cases in, the picture of your test cases, which is now visually represented, should pretty much look like your requirements. And it's a little bit like the classic where you have the picture of the swing, where the swing goes through the middle of the tree, or it's got the swing's pointing out, not in. And actually, quite often when you look at a reverse engineered set of test cases, it doesn't look like the requirements it's supposed to be testing, which is in itself a good static test that you really need to go back and kind of rethink some of those test cases. So the flowchart should fully represent the system under test. The optimized set will reduce the amount of testing. So what we'll do now is once we've got that, we're actually going to run through and try and come up with a new set of test cases. And the other great advantage of this, if you've got it perfectly right and your test cases are spot on, great, that's fantastic, you've done a great job. The advantage of having it in this is that if you then make a change, so you might have something like enter username, you might have if username blank, and you put that in as a logic gate now, then we would automatically make the change to the test cases for you. You don't have to go through manually and change those test cases. So doing this anyway gives you ongoing change, and you could use this just at the event of I've changed my logic. So instead of going through all the test cases by hand, I'm just going to import them, optimize them, and then make the change. So that's actually quite a useful sort of technique of being able to do this. So if you just look at what we've done on that one, now the thing you've got to be, there were 24 nodes or design steps, and there were 22 decisions. The 22 decision is once you came out of a design step, you went something else. Once we've optimized it, there were 12 nodes, 20 decision branches. So we actually reduced the number of the amount of testing by 50%, and we actually then moved up to 100% functional coverage. It is not magic. You do have to think about it, and you do have to kind of do it alongside the requirements. We've built a lot of automation in there, but you do have to sit and think, and you also need to make sure that the diagram you've come up with at the end is correct, and you haven't made some kind of blunder. But it can be an incredibly effective way of cutting the cost of your existing test cases and also making changes to them. As I mentioned, the ability to kind of move your tests up and down. So if you do any work in designing some test cases, then it's very easy for, if a programmer's built some test cases, then it's very straightforward for a system tester or a functional tester to just pick those up and actually use those logic diagrams to actually build the test cases that they're interested in. So advantages can be imported, exported as required into numerous forms. Mostly Excel if you've got kind of manual things or you're coming out of things like other products. But if you've got Quality Center or ALM, then it's pretty straightforward to just drag and drop. Coverage metrics give you fully quantifiable costings based on the test case cycle. It's pretty easy to recognize incorrect flows, missing functions or new functions. By sort of reverse engineering, it's fairly obvious. And as I mentioned, automatic handling of change. If you change something, it's pretty easy to be able to kind of track which test cases need to change. So just to kind of summarize, Agile Designer provides, and it helps you build better requirements, undoubtedly. And the reason for that is that it's drawing out the logic stuff. It removes all those ors and ands and sometimes and otherwises and a cadence, and actually puts it into something which is more akin to a specification of an electronic circuit board earlier, and that drives out that drives clarity. It forces you to think a little bit harder. It's going to basically the other advantage we find is because you're actually entering less language into a box. You should really restrict yourself to 1 or 2 sentences. It actually it's less. It's easier not to make mistakes when you're only putting a couple of sentences in. It's also easier to audit. Obviously, we're putting the logic, and we're forcing through use cases. Estimating complexity, which I talked about, using testability. And if you look at our website, there's a very good webinar on that. And creating the perfect set of test cases, which is 100% coverage, risk-based, and path modeling. When I say risk case, when I said 100% coverage, one of the things you may decide to do is that, our optimizer might look at your functional logic gates and say that there's 52 test cases. You might not have time to do those test cases. And what we can do then is you can set various components in the graph to have a higher importance. Then when we build our test cases, we will skew them to reflect the more important test cases. And that allows you to say, look, we have tested 50% of our test cases. We've got 62% functional coverage, but we are testing the most important bits, which is the shipments and the returns, to 100%. And that's very important, and that's a real pragmatic way to think about it. Improving existing test cases, which is basically the idea of being able to import them, optimize them, put them out, link test cases to change, and to create and manage my test data. Some people use these just on their own. Some testers that we know just literally use them to build test cases. A company in Holland just does that. They literally just import their BPMNs, do their business processes, build the test cases, and then they put them out as spreadsheets and they put them then back into Quality Center. It would make more sense if you use them in conjunction, because any work, you do one thing and you get multiple things out of it. standalone process embedded in your software lifecycle, and of course, the mantra of everyone nowadays, which is earlier delivery and higher quality. Good old shift left, and I think that's pretty much everything I was going to talk about. I suspect there's probably been one or two questions. So what I'm going to do now is just kind of hand it back to Mihai. Is it possible to run the poll now?
Well, thanks to you. Yes. So I'm ready to start with the polls now, and then we're going to take the questions. So, ready when you are, Anna-Marie. Okay, so folks, thanks for listening. The first poll is the first question is: do you use any formal test case design methodology? And the answers are yes, no, and partially. And if you are wondering what test case design is, then don't even answer the question. All right, we'll give you about 30 seconds to respond.
I can see the votes are coming in. And,
all right.
Well, I think we should close it now. It's almost going to close it, and then here is the results.
Okay, so Hugh, does it meet your expectations here? Certainly meets mine from a testing perspective.
Sorry, I can't actually see the results here, so I need to just have a look.
So it's yes 19%, no 39%, and partially 42%.
Okay, that's pretty much kind of what I'd expect actually. That's pretty good. Okay, good.
All right. Next poll. Let's start it up, Anna-Marie, please.
Yes, here you go.
Okay. Do you have metrics? Right. So thanks. So do you have metrics on how much functional coverage your testing actually has? So the question is, do you have metrics on how much functional coverage your testing actually has? And the answers are just the same as before: yes, no, and partially.
Okay, I think it's... I'll close it now and I'll share the results.
All right. Thank you, Anna-Marie. So here we've got the following responses: yes, 35%, no, 45%, and partially 20%.
So I'm interested in the 35%.
I'm also interested. I was actually going to say the same thing. We're also struggling with teaching our project teams how to measure functional coverage.
Yeah, I think 35% is being a bit optimistic, but I stand to be corrected. So if one thing we've actually done quite a lot of is people actually send us their requirements documents and their test cases, and we do a little mini audit, and it's actually quite an interesting exercise. It's a little bit like in Britain it's called an Ofsted, where someone comes in and kind of tests how good you are at your job. But I would say 35% does sound a bit high, and I'd really like to kind of see some of those, but we'll take them as read for the moment. Anyway, moving on to the next one.
Right. Okay. So that'll be subject for next webinar to actually see how the functional coverage works.
Yeah.
Right. So so now the next question is: do you have a data management framework? And the answers are again yes, no, or partially. Although I don't see how anybody can have a partial test data management framework.
Well, they do. Some people will do like a basic masking and basic subsetting, but they don't really link test cases to test data. For example, they think of test cases, test data, test case by test case. They'll go into each test case and say, I need this test data for it, and then they move on to the next test case. That would be kind of the sort of ultimate. Or other people just think of it as an environment issue. So when I say partial, it's whether you've really taken it to the kind of the nth level.
No, I agree. We had one of these horror stories in South Africa where somebody said to us that test data forms part of test environments, and that we shouldn't be worried about it as testers because they're going to use live data cut out of production. So
yeah, so why do you need testers? Just use production. Yeah, exactly. We're not going to worry about edge. We're not going to worry about edge cases. We're not going to worry about negative testing. Let's just bung it in and hope for the best. Yeah, excellent. Sorry,
right. So the poll results are back now on the test data management framework. The answer is 21% yes, 56% no, and 24% partially. Which is exactly what we're discussing about.
Yeah, I would say that's very accurate. That's pretty much what we've come across actually. So that's quite useful, that one. Good.
Yeah.
Right, good.
Right. Next question. Excuse me. Okay, Anna-Marie, are we done with the polls, or do we have the last question?
No, we have 3 poll questions, and we just had them. So
we're done.
Back to you for the Q&A session.
Great stuff. So, Hugh, are you prepared? We will throw rocks at you.
Go for it.
All right. So we will start with the first questions that are actual real questions. Let's take the question from Christopher Scher. Will there be any real-world examples in this demo? The light bulb and NB examples are nice, but they're relatively simple in comparison to a real-world application. The question is, Hugh, do we have real-world example here?
I mean, it's a little difficult because most of those real-world examples would be sort of something that you would deal with in terms of customer type systems. So I mean, if you look in our examples, we've got loads and loads of different ones. If you're looking at something like an iPhone, you're looking at 65 potential paths through something like an iPhone sending a text message. So those are sort of slightly more real. It's a little difficult. I mean, some of the real-world examples you get into literally hundreds and thousands of potential paths to go through. So we've just taken, what we've tried to do with our examples is kind of show off the different techniques. It really doesn't take much for you to build these. I would just encourage you to take a process, build it yourself, and then just look at the optimization techniques that you go. Even if you get it down from 300 to 10, that's massive. If you get it down from 50,000 to 23, then it's enormous. So yeah, sorry, I'm just sort of using some of the examples we've picked up over time, really. So.
Right. Okay. Thanks, Hugh. Well, Chris is going to have to wait for that one. So, by the way, Chris is a member of it, so that's why the short little arrows pointed at.
Yeah, that's fine.
Right. So, okay, the next very valid question comes from Sherry Carmouche, and the question is this tool used only for Agile, or is it adding value for waterfall as well?
That's a very good question. I would actually, most of our customers are waterfall, strangely. They've realized there's a problem. I mean, there's a really good one the other day. They built about sort of, 150 regression tests for, I think it was an SAP system. But they actually went through them and they realized they were pretty much worthless. And that instead of running the 150 regression tests before they did an upgrade, they decided it would be better to go back and to design a whole bunch of better test cases. So that's pretty much a waterfall, type approach. They're actually kind of designing their test cases and kind of, running through a sort of typical 3 to 4 month cycle to be able to do that. So actually, I would say it's mostly waterfall that are kind of reaping the benefits. It's sort of giving you a little bit of agility in a waterfall world. People are using Agile. It's probably about 20% of our users are actually using it in Agile.
Well, it depends, because in my world, I've seen Agile used properly in very, very little amount of clients. So
yeah.
Most of them are full of E, so it doesn't really matter.
Yeah. Anyway,
right.
So a very good question. Thank you.
Right. Well, Sherry will probably thank you for that. We have a next question from Abu Ahmed. Is this test case or flowchart application in QC?
In QC. You mean, do we store it in QC? Is that what you mean?
Well, I'm not sure exactly what the question is, but I would imagine that is this available with QC?
Yeah. I mean, basically, think of it as an accelerator for QC. I mean, basically, it's a bit like Visio. Think of it as Visio for Quality Center. So you can, in effect, all of the artifacts that get created. So you could take this, and you could actually just push that out into a Word document. and that Word document is actually going to actually then just be attached to as a requirement, which is then going to sit inside Quality Center. So that's actually it's actually going to build you a Word document, which it's doing right now, and then that gets attached into as a requirement, as a normal requirement module. There is actually a very interesting question, which I'm going to kind of jump ahead on, which is actually the idea of business components. As people move more into business components, we can actually just use business components of Quality Center, and that's a really, really good way of doing it. So if you actually break your application down into these kind of more sort of logical, abstract terms, then what we would do is we would drag those onto the palette. We will then use this then to drive the, I'm going to create
Do you have multiple languages?
we're actually we've just switched to German, and so the actual whole product will actually start up in German, and the next one, strangely, is Spanish. So we will be putting a Spanish version out probably in the next say about a month. So Spanish is the next one. Sorry, we did German first. We just happened to have a German speaker who works for us, who did it. So now we're going to be moving on to Spanish next.
All I can say is ole. Right, so let's move on to the next question. The next question is related to, is a commercial question. How much is the product and the license policy? So
if you go on the website, you can look it up. But basically, the way that we're thinking of license, or the way that it's really licensed, it's more to think of it. You pay for it sort of on an annual basis. So you might have a project spin up, and you might need sort of 4 or 5 Agile Designer licenses for the life of a sort of a project, which say between 6 months to a year, and then you can just maybe just go back to 1 or 2 of them. So we're trying to make it kind of on a sort of annual basis type purchase.
Okay, and let's take, I see we're on the dot on top of the hour, so let's take one more question and we'll be done. Do you have any development groups using this activity, and how can pull requirements be used with this model?
How can pull requirements? Okay, development groups, absolutely. We've got sort of loads of software development lifecycle teams who've used it to come back and clean up a bit of a mess that they've done, and some are using it for brand new development. They literally just the developer comes in, they build a flow chart based on the requirements that they've seen, and then they go back to their users and testers and say, is this what you need? Now, the other problem, which is actually a sort of slightly more difficult problem, is really the idea of being able to actually try and build requirements out of build a flowchart out of bad requirements, and that is much more difficult because you've got to take text which may well be sort of fairly ambiguous. So you might actually have. So I'll just quickly show some of the text importers. So you might take something which sort of looks like the leg before wicket rule, and you've got that, and you've now got to somehow convert that into a flowchart. Now, what happens is you do actually have to use your brain. We can take that text, and we've got to make, is that a decision? Can it be given out if either? Can it be given out if a no ball, etc.? So we do break it down into smaller blocks, and I would say that's probably the first thing to think about with bad requirements, is to try and isolate out of the text the things that you're sort of that you're struggling with. it is quite effective. I've got to say, once you've drawn a picture and you go back to the user who's defined the Word document, the original wall of words, it does flush it out. It really does flush it out. During our training course, actually, what we ask is that we split the team in two, and we ask them to build a requirements using a flowchart and also using words. And it's amazing how much one team is doing it by writing it down in text, and the other team's doing it writing it down in a flowchart. And it's amazing how much more effective, using the visual cortex is in terms of being able to build that requirement.
All right, great stuff. So I believe we are done with the time now. Any other question will be answered by you and posted as part of the recording, as part of the collateral for the recording. So on this note, I'd like to thank you for his very valuable presentation, and I'd like to thank the Vivid group as well for organizing it, and for everyone that has attended for taking the time in the afternoon and joining, or in the morning, depending on your time zones. So without further ado, thank you very much, everyone, and have a great evening.
Thank you, Mihai. Thanks a lot, everyone. Bye-bye.